Okay, so now we're going to start talking about rational functions. Before we do, though, we need to start talking about operations between functions. So if we look at what does it mean to have operations between functions, in math we have four main operations: add, subtract, multiply, and divide. Well, that's exactly what we're going to do. We're going to look at how do we add, subtract, multiply, and divide with functions. So whenever we add with functions, add, subtract, multiply, or divide actually with functions, it can always be written one of two ways. So if I look first at addition, I can write it like this: f plus g of x. This is just saying that I'm going to take my function f, whatever it's defined as, and add to it my function g. It is also sometimes written f of x plus g of x. So like I said, it can be written both ways, but that's all I'm going to do if I see f plus g of x. If I see f minus g of x, all that's telling me to do is take my function f of x and subtract from it my function g of x. The thing to be careful of is when I'm using subtraction that I put parentheses around my whole entire g of x, because I need to show I'm subtracting the entire function, not just the first term of it. So I have to remember to use parentheses and distribute, and we will look at a couple examples with subtracting. Multiplication, f times g of x is the same thing as f of x times g of x. And then finally, f over g of x is the same thing as f of x all over g of x. So the big thing to do when we use our function operations is perform whatever operation they're asking me to do, and then oftentimes they're going to ask me to state my domain. Remember, domain is all possible x values. We're going to learn that what I'm about to say isn't 100% accurate in the future, specifically next year. However, for now, I'm going to say that the domain will be all real numbers. That's a symbol for real numbers. So in your notes, if you don't know that symbol, make sure you write out real numbers. So all real numbers, unless there is a denominator. Then we have to ask ourselves, is there anything that would make my denominator 0? Because I cannot have, let's do this, I'll write denominator cannot be 0. We have actually talked about this before. Remember, we talked about how, it's okay to have 0 on top, but no, it's not okay to have 0 on the bottom. So this is where we're going to be focusing when we're asked to list the domain. So I have 3 examples for us to look at, and then I have one final example that I'm going to ask you to do and bring in with you to class. So let's look at the first example. Suppose that I have this function f of x, it's negative 2x plus 6, and I have a second function g of x, is 5x minus 7. I'm asked to first find f minus g, and then find f divided by g. Well, f minus g, all I'm going to do is take my f of x minus my g of x. Again, I remember my parentheses. I notice that these parentheses weren't necessary. There isn't anything to distribute, so I'm just going to get rid of them. These parentheses, however, are important because I'm going to have to first distribute that minus, giving me minus 5x and plus 7. Sign belongs to the number. Negative 2x and negative 5x is negative 7x. Positive 6 and positive 7 is a positive 13. My new function that results when I subtract g from f is negative 7x plus 13. As far as the domain goes, because there is no denominator, I can say that the domain is all real numbers. Anything will work. But what about the division part of it? What is f over g? Well, f over g is going to be negative 2x plus 6 over 5x minus 7. And a lot of times with dividing, I'm not done until I've factored. So I'm going to go ahead and think about all those times we factored, and I'm going to factor the top because it has a GCF. I can take out either a 2 or a negative 2. Let's say I take out a 2. I get negative x plus 3 all over 5x minus 7. So nothing cancels, so I'm going to go ahead and leave this as my final answer. In order to define my domain, I'm going to say that x cannot equal, well, actually let me do it this way instead. I'm going to say that my denominator cannot equal 0. Solving this, I'm going to add 7, and I'm going to divide by 5, giving me x cannot equal 7/5. So there would be my domain for this one. Like I said, I do have a total of 3 examples and then one for you to try as homework. So moving on to example 2. Now I'm asked to find very similar f of x minus g of x and f over g of x. So notice that now the other one looked a little bit different, but they're still asking the same thing. This would be a really good one since we just did one like this if you did want to try pause it and try one on your own. So looking at the first part, if I want to find f of x minus g of x, all that's telling me to do is take f of x, I'm going to start with them in parentheses and then determine if the parentheses were necessary or not, minus g of x. It looks like the first set of parentheses were not necessary, but the second set is. I'm going to have to distribute that minus in. Combining like terms from here, I have an x and a negative 5x to be negative 4x. I have a positive 3 and a negative 6 to be negative 3, and I have a minus x squared. It's usually best to put your answer in standard form. And because I don't have a denominator, my domain is all real numbers, and that would be my final answer there. Part 2, or part B, asks me to divide. So f over g would be f over g. And as I said before, I need to be able to factor. So I see that the bottom I could use a factor sum table and do factors of 6 with a sum of 5, which would be x plus 3 on top. 2 times 3 is 6 and 2 plus 3 is 5. So I'll do x plus 2 and x plus 3. Since there is multiplication here, I can cancel out my x plus 3's. When those cancel, I'm left with x plus 2 on the bottom, and on top I'm left with 1. Now, when I go to list my domain, I have to look at what would make my denominator 0 before I canceled. So I can either look here at what I was originally given or look here at my factored form. Well, my domain can't be 0, right? It's easier for me if I have 2 things multiplying, because if 2 things multiply to be 0, or if 2 things multiply to not be 0, it solves the same way. Either x plus 2 cannot equal 0, or x plus 3 cannot equal 0. Do you remember this? So x cannot equal negative 2, and x cannot equal negative 3. So here's my simplified answer, and my domain is right down here. Okay, looking at the third and final. Okay, I'm asked to find for part A, f times g of x, and for part B, I'm dividing one last time. So if I want to do f of x times g of x, again, I start by putting them in parentheses and then determine if they're necessary. From here, since it's multiplication, I can go ahead and FOIL or distribute, and I get x squared times x to the 4th is x to the 6th. Remember, I add my exponents. Minus x squared plus x to the 4th minus 1. There's nothing that I can combine. Again, when I state my domain, I do not have a denominator, so I'm all real numbers. Part B asks me to divide. So f of x divided by g of x would be x squared plus 1 over x to the 4th minus 1. I try to factor. I notice on top I can't factor. However, on the bottom, I see I have perfect square minus perfect square, where the first thing being squared is x squared, and the second thing being squared is 1. So using that formula that we learned a while back now about factoring, perfect square minus perfect square becomes a plus b times a minus b, where in this case my a was x squared. Well, notice what this does. This allows me to cancel out my x squareds. Canceling out my x squareds, I get 1 over x squared minus 1. Well, that will be my simplest answer. If I wanted to, I could factor the bottom further, 1 over x plus 1, x minus 1, and I'm going to ask myself, what would make my denominator 0? Remember, I have to look at my original denominator. So when does, I'm going to have to use a little room over here, x squared plus 1 equals 0, and when does x squared minus 1 equal 0? Well, x squared equals negative 1. Well, that means that x equals plus or minus the square root of negative 1, which I don't have to worry about. because that's an imaginary number. So then looking at this next side of it, x squared minus 1, that cannot equal 0. I can add 1, that means x squared cannot be 1. That means x cannot be plus or minus the square root of 1. So x cannot be plus or minus 1. And there would be my simplified answer with my domain. We are going to start talking about something we call composition functions. To get us ready for that, I'm going to ask you to complete the following problem. Do the best you can. Try to show some work if you can to try to help you figure it out. It is multiple choice, so there's no reason why you can't come in with an answer chosen. But if you can have that done for your next class and hang on to it if you're ahead in the videos and you're watching it before this video is actually assigned, make sure you do this and just hang on to it for when we're ready for it.